Number 2 says to graph a system of inequalities. You are going to have to do this on the test. On the test, I give you a coordinate plane that's all scaled out and everything. But on here, I don't have one, so we're going to have to draw it in. So let's first draw our coordinate plane, your y-axis and your x-axis. Okay. Let me do that. I did. Okay. And then, can someone tell me, probably in that systems of equations packet, you wrote down somewhere, what are the steps in graphing an inequality in two variables? What are our steps to graph an inequality? What do we first need to do when we want to graph something like this? What do we do first? You guys are going to have to do this by yourself in a minute. What do we do first?
You have to find the slope.
That's on the right track. The first thing we want to do is we want to take the inequality and we want to write it like an equation. You change it to an equal sign. So that first one, y less than 2 equals, so it becomes y equals 2. Y equals 2. Okay. This is either a vertical or a horizontal line. And I know that because it only has one variable. Usually we have two. Usually we have x and y, right? This time it's just y equals a number. We've talked about this before. When we see y equals a number, what does that mean? That's what y is. Yeah. Yeah, and that's what y is for the whole entire line. When we see y equals a number, that means it's a horizontal line. Horizontal. So what it means is I go up to 2. So on my coordinate plane, I should have lines on here. So 1, 2. And at y equals 2, I have this line going on all the way across along 2. But am I going to use a solid line or am I going to use a dotted line? A dotted line, right? Because it's just less than. It's not less than or equal to. So we do a dotted line. Okay. Okay, now the next one. This one, is this written in standard form or in slope-intercept form? Slope-intercept. Okay. Let's rewrite it as an equation. So instead of the inequality, I'm going to put an equal sign. Y equals 3x minus 2. Okay. And let's first figure out what's our slope. What's my slope? Yeah, 3. It's the number being multiplied by x. And now what's my y-intercept? Negative 2. Negative 2. So that tells me on my graph, I go down to negative 2. And at that point on the y-intercept, or on the y-axis, that's my y-intercept. I'm going to have a point there. And then if my slope is 3, what's my rise and what's my run? Yeah, 3 over 1. 3 is my rise. 1 is my run. So from the y-intercept, this is my starting point. I don't start at 0. I start at my y-intercept. I go up 1, 2, 3, and then over 1. And now this time, do I use a solid line or a dotted line? Solid, yeah. solid because it's greater than or equal to. Okay. Now I have 2 more things I have to do. Perfect. Yeah, we need to test a point. We need to test a point and check it using the purple, dark blue line. I don't know what color that is. And then test it also using the light blue line. So let's do this dark blue line first. So we want to test a point that's not on this blue line, on this dark blue line. We have to test something either above or below. Can we choose a point? Can someone tell me an ordered pair that's not on this line? What's the one that I said is like the easiest to use? 0, 0. Good. Good. So that's 0, 0. And I'm going to plug that in to my inequality. I know there's not a lot of space on here, so I'm sorry. 0, 0, and I plug that in to y less than 2. So I plug in 0 for x, but there is no x. And I plug in 0 for y. And I check to see, is that true? Is 0 less than 2? Yeah. Yeah, 0 is less than 2. That means I shade the part, shade the half that contains that point that I just tested. So I shade everything below this dotted line. Okay. And now I need to do the same thing with the second inequality. What point should I test this time? I could do the same exact thing. As long as it's not on the line, which this is not, I can use it. So I'll use 0, 0 again. This time 0, 0 is going to get plugged in to y is greater than or equal to 3x minus 2. So I plug in 0 for x, 0 for y, and I check to see, is that true? Is 0 greater than or equal to 3 times 0 minus 2? Or simplified, 0, is that greater than or equal to 0 minus 2? Is that true? Yeah, 0 is greater than negative 2. Yes, that's true. So then that means I'm going to shade the part that contains that point again. So this time it's going to be like the left side of that light blue line. So everything to the left of that line gets shaded. And where is my solution? Where is my solution now? Yeah, where the two colors mix. Where those two different half planes, where they intersect. That whole region right there. Okay. Right. Let's go through number 3 now. So for number 3, we are solving an inequality. Solving an inequality. Solving an inequality is really, really similar to solving an equation. Did I copy that down right? Negative 2x plus 5 is less than 13. Yes. So if I want to solve this inequality, that means I want to get my variable all by itself. Where is my variable in here? X. Yeah, I want to get x by itself. What's in the way of x being by itself? And well, so it's going to be this negative 2, right? And the 5. So I got to get rid of the negative 2 and the 5. Which one do I need to get rid of first? Who said that? Yeah, the 5, right? Yeah, how do I get rid of the 5? I subtract 5. Subtract 5 from both sides. And then I simplify, so I get negative 2x, and then plus 5 minus 5, that cancels out to 0. I pull my inequality down in the same exact direction. And then what's 13 minus 5? That is 8, yes. Okay, and now how do I get my x by itself? Divide by negative 2, which means I have to divide the other side by negative 2. Okay, so my negative 2 over here, those guys cancel out. I'm left with just x. Now what do I need to do? Yeah, what do I have to do with the symbol? I have to flip it. I have to change the direction because I divided both sides by a negative number. So now it's not going to be less than, it's going to be greater than. And then 8 divided by negative 2, that's negative 4. Okay. And then you'll need to draw out a number line and graph that as well. But I think you guys can do that, so I'm not going to go over it right now. We're going to go over this last one, and then you'll have the rest of the class to finish your test. Okay, so for this one, John wants to visit his aunt in Australia next summer. He estimates that he's going to need $1,200 for the trip. His father said he would give him $550 toward the trip. John has a part-time job and thinks he can save $75 of his earnings each month. So we're going to write and solve an inequality to determine how many months John will need to save in order to have enough money for the trip. So let's make our way through the problem. And let's just go through and circle all the different numbers because those are going to be the most important pieces for us. So there's this $1,200. That's the total he's going to need for the trip. Let's write that down. Let's use a different color. Oh wow. Okay. So 1,200 is the total, right? And then his father said he would give him 550. So what are we going to do with that 550? How does that relate to the 1,200? Add it. So now his dad is helping him, so the trip is going to cost more money. It's going to cost less money, right? Yeah, it's going to cost $550 less. So let's subtract 550. So that's how much his dad gave him. Okay. Okay, so let's solve that. So what's 1,200 minus 550? 650, good. So 650 is the new total. That's how much he's going to have to save now, right? New total. Okay. Okay, and then what's the last number we have in here? 75. And what does that 75 tell us? He can save $75 one time, or how many times can he save $75? Each month. So for every month he works, he's going to save $75. So after 1 month, how much would he save? How much would he save after 2 months? How would you find it out? Add it? Yeah. How did you find that out? Yeah. You added it, so 75 plus 75. The other way we can think about it is multiplying it, right? We multiply 75 times every month he works. So we want to know, so 75 times m being the number of months he works, 75 times m, that's going to be the amount that he's able to save for the trip, right? So we want this 75M to be, how much does he need for the trip in total? 650. So we want 75 times M to be greater than or equal to 650. Okay, and then the question is we want to determine how many months he's going to need to work in order to save. So if M tells us how many months, how are we going to find out what M is? What do we need to do in this inequality? How do we solve for M? Add 75? Divide by 75. So I divide one side by 75, divide this side by 75. 75 over 75, that gives me 1. M is then, do I need to flip my inequality this time since I divided? No, why not? Right, right, exactly. So now that stays exactly the same. M is greater than or equal to, someone get out their calculator and divide that for me. 650 by 75. Yeah, 8.6. 8.6. But we're talking about like just whole months, right? So we're going to round up and say he needs to save for at least 9 months before he can go visit his aunt in Australia. M is greater than or equal to 9. He must save for 9 months. Okay. Any questions on those three? Yeah, it's a lot to pack in.